Okay, so in these examples, rather than use radicals, I'm going to use rational exponents to solve them. But you need to remember what I told you in the beginning of this chapter about rational exponents, how they relate to radicals. So let's say I wanted to solve x cubed equals 1,000. Well, you know that if you raise a power to a power, you just multiply exponents. So one way to get x would be to take x cubed and raise it to the 1/3 power, because then 3 times 1/3 would be 1. So this would simply be x to the first power. So then that would just give me x. So if I raise this side to the 1/3 power, that's just going to give me x. Well, then I would raise 1,000 to the 1/3 power. Now, if you think about what happens when you raise something to the 1/3 power, you just take the cube root of it. So if you raise 1,000 to the 1/3 power, that's just the cube root of 1,000, which is 10. And by the way, if you put this in your calculator, you can actually raise 1,000 to the 1/3 power on your calculator, but if you do that, make sure you put the entire 1/3 in parentheses. So it would look something like this. Like this here, it would look like 1,000 raised to the, and then you'd put the 1/3 in parentheses. And then when you tell it to do the operation, it should give you 10. Okay, so here I have x to the 4th minus 1 equals 80. So I'm going to go ahead and isolate x to the 4th by adding 1 to both sides. So if I add 1 to this side, it'll cancel the minus 1, and 80 plus 1 is 81. So now I have x to the 4th is equal to 81. Now over here, remember, I raised x to the 3rd to the 1/3 so that I would get x. Well, if I have x to the 4th, I can raise it to the 1/4 to get x. Okay, now here's something you have to be careful about. When you raise a number to the 1/4 power, if you apply this is like the 4th root. When you apply an even root to a number, technically the answer is plus or minus that value. And I'll show you that in a minute, show you how it checks. But so basically I'm taking the 4th root of 81 with a plus or minus in front of it. So the 4th root of 81 is 3, and so the answers, there's two answers, plus or minus 3. Now, if you plug 3 in here or minus 3 in here, it doesn't really matter which one, but if you raise both of those to the 4th power, you're going to get 81, and then 81 minus 1 is going to equal 80. So both of these answers happen to be solutions. And so that would be, I would also do it if I had raised both sides to the 1/2 power. So, you know, when you have to apply the power, you've got to do the plus or minus if the power involves an even root. On an odd root, you don't have to worry about that. Alright, so here I have x to the 5th equals 243. So I'm just going to raise both sides to the 1/5 power, so that this will just be x. And then 243 to the 1/5 power, that would be the 5th root of 243. And if you check, you'll see that 3 times 3 times 3 times 3 times 3 is 243. So 3 is the 5th root of 243. Okay, so here's another even power here. So I have 3x minus 2 quantity squared. And to get rid of the square, I can raise this side to the 1/2 power, but when I apply the 1/2 power to the constant, I have to do the plus or minus. Now, the 81 to the 1/2 power is just the square root of 81, so I end up with plus or minus 9, and then I can add 2 to both sides to get rid of the try to isolate the x. So add 2 to both sides, and I get 3x equals 2 plus or minus 9. And then divide both sides by 3, so I get 2 plus or minus 9 over 3. Well, 2 plus 9 divided by 3 would be 11/3, and then 2 minus 9 divided by 3 would be negative 7/3. So those are your two answers there. Similar problem here, but since I'm going to raise both sides to the 1/3 power, because if I raise something cubed to the 1/3 power, it'll cancel the power out. And then that would be, I would also have to raise 8 to the 1/3 power, which is just the cube root of 8. So that's going to give me 2. and then you just add 1 to both sides, and you get 3. And then here's another one. Not really sure why I did 2 that are very similar, but x minus 1 to the 1/3. You can just read this. Just do this one just like I did the one before it. It's basically the same type of problem. Okay. I see what I did. Here it was x minus 1 cubed, so I had to raise both sides to the 1/3 power. This one is x minus 1 to the 1/3, so I had to raise both sides to the 3rd power here, because if you have 1/3 and you multiply it by 3, you get 1. So that's just going to give me x minus 1 to the 1st. And then I have to raise this side to the 3rd power. 3 cubed is 27. And then add 1 to both sides, and you get x equal 28. So I thought they were the same type of problem, but actually they're not. Okay. Now, what if we have problems like this? So if I have 3x minus 2 to the 4/3, well, the way to get rid of the 4/3 is to raise this to the reciprocal power, raise it to the 3/4. And again, it's because when you raise a power to a power, you multiply exponents. So really, that would be 3x minus 2 to the 1st power. So, or just 3x minus 2. So anyway, raise that to the 3/4. Now again, I'm applying an even root here, so I got to do the plus or minus thing over here. But I have 81 to the 3/4 power. Now, remember what I told you. This is the root, so I need the 4th root of 81, which is 3. And then the numerator here is the power. So I've got to take the 4th root of 81, which is 3, and then I got to raise that to the 3rd power. Okay? But I have to do that for plus 3 or minus 3. Well, plus 3 quantity cubed is 27, and minus 3 quantity cubed is negative 27. Okay, so now let's isolate the x. We can add 2 to both sides, and we get 3x equals 2 plus or minus 27. And then divide both sides by 3, and I get 2 plus or minus 27 over 3. Well, 2 plus 27 over 3 is 29 over 3. And 2 minus 27 over 3 is minus 25 over 3. Okay, now here I've got this raised to the 3/2 power. So in order to get rid of the 3/2, I got to raise both sides to the 2/3 power, the reciprocal of 3/2. So, and then I might raise the other side to the 2/3 power as well. Well, now this just eliminates the power, so I just get x minus 1 by itself. And remember, this is the cube root of 8, then you square it. So the cube root of 8 is 2, and then I square it, so that gives me 2 squared. So I get x minus 1 equals 4, or add 1 to both sides, x equals 5. Okay, the last one I wanted to do a negative exponent. And so if I have a negative exponent, I'm still going to raise it to the reciprocal. But what's the reciprocal of negative 5/3? It would be negative 3/5. Okay, so if I raise this to the negative 5/3 to the negative 3/5, it will eliminate the power, and I'll just get x minus 1. But now I have to raise 32 to the negative 3/5. Well, remember, that's actually 1 over 32. That's 1 over 32 to the positive 3/5. So let me write that in there for you. Okay, so that's going to be 1 over, then I have to say, what's the 5th root of 32? Well, the 5th root of 32 is 2, and then I have to cube it. So I actually get 1 over 2 cubed, which is 1/8. So I have x minus 1 equals 1/8, so x equals 1 plus 1/8, and then get a common denominator. 1 plus 1/8 would be 8 over 8 plus 1 over 8, which is 9/8. So that's the final answer. Now I wanted to end this with another radical problem, and I wanted to show you how nasty these can get when you have more than one radical that pops up in a in a problem radical equation. Okay, so here I have square root here minus another square root here equals 2. Okay, I can't isolate both radicals, but I can certainly isolate one. Let's take this term, this minus square root of x plus 4, let's move it over to this side, and then that will make it plus square root of x plus 4. So we just move it over to the other side and change its sign. Now, I'm going to square both sides. So if I square this side, so if I square this, that's just going to eliminate the radical, and I get 4x plus 5. Now here's where it gets a little nasty. Here, when you square both sides, you have to square the 2, which you get 4. And then using your formula for squaring a binomial, you have to double the product of the 2 and this radical. So 2 times the radical, and then if I double it, I get 4 times the radical. So that's the middle term. Then I have to square the radical. Well, if you square this radical, it just eliminates the radical, and I get x plus 4. Now, what I'm going to do next is I'm going to take this 4 plus this 4, which is 8, and then I've got the x. So I've got 8 plus x plus this radical here. Okay, now what I can do next is I can subtract 8 from both sides. So if I subtract 8 from here, it's just going to cancel the 8, and then 8 from 5 is going to give me minus 3. And then if I subtract x from both sides, it's just going to cancel this x, and then 4x minus x is going to give me 3x. So that's all I did. I just subtracted 8 from both sides, then I subtracted x from both sides. And that just leaves me with this radical on this side. Okay, now that I've got the radical isolated, I can actually square both sides again to eliminate this radical. So if I square both sides again, I would have to square this binomial, and then if I square this, then I have to square this radical. Now squaring this binomial, you have to square a binomial, use this formula for squaring a binomial again. So I square the first term, I get 9x squared. Then I double the product of these two factors, so that would be minus 9x doubled, so that's going to be minus 18x. Then plus this squared, so that's going to give me 9. And then when I square the 4, I get 16, and when I square the radical, I get x plus 4. Okay, so in the next step, distribute the 16 through, so I get 16x plus 64. Then subtract the 16x from both sides. So if I take 16x away from this side, it's just going to cancel it. And if I take 16x away from this minus 18x, it's going to give me minus 34x. Then subtract 64 from both sides. So subtract 64 from the right, and it's going to cancel. And then 9 minus 64 is actually negative 55. And now I've got a quadratic equation equal to 0. Now, if you factor this, you'll find that it factors into 9x plus 11 times x minus 5. And then if you set 9x plus 11 equal to 0, you get x equals negative, actually I've got that backwards, it should be negative 11 over 9. It doesn't really matter though, because that answer is not going to work. So it should be negative, negative 11 over 9, not negative 9 over 11. So that's one answer. And then if you set x minus 5 equal to 0, you're going to get x equal 5. Okay. Now, when I checked these, remember we had to check these. So when I checked it, the negative 11/9 didn't work. So I had to toss that one out. The only answer that worked when I went back and checked it was x equal 5. Okay. So that is how you solve one of those nasty problems that requires you to square twice within the problem. Okay. I've got one last video. It'll be very short, and it's going to involve some applications of radicals and the Pythagorean theorem.